Hello friends, welcome to C# Intermediate to Advanced tutorial. Now you are watching part 4 of the subseries C# Background Worker Component. Here we are going to implement vowel count task, and we will also see how application becomes not responding when user interacts with any of the UI element here when background task is going on. So let's quickly review the previous slides. First we learned the need for background worker component. Then we talked about the example, what we are going to implement. Then in the previous video we learned properties and events of background worker component. In this video we will just provide a dummy implementation for all these three events, and in the next coming videos we will start adding the code on these handlers. So first let us look at the vowel counting. Here we included system.threading by making use of the using directive. Then we declared a boolean variable cancel work. So the cancel work is initially assigned to false. Then we have count meters, count A, E, I, O, U. We know that our application is having 5 text boxes, right? So those text boxes will read the counter from these variables. So for our demo we declared these class level members, and this will be accessed by both UI as well as background worker component. So we have to do a proper synchronization, but in our application just for demo purpose we doesn't do any synchronization. So there is a thread safety issue, but here since this is just a demo we don't dig much into that. So the variables here will be read by the main thread and updated by the background worker component. In that way here we are avoiding the synchronization issue. So if you see here, these are all our count meters A, E, I, O, U, and there will be a corresponding members. So when the background worker reports the progress, at that time we not only run our progress, we also read the content from here and we will display it. So even though it's not real time, that means yeah, 10 character delay we can say, not even 10 character delay, 1% delay. So how many character it will come, it's based on that. So those delay will be there, and we update whenever the report progress is reported here. Alright, first we define a helper function check vowel A, and input here we are processing it as a C. So what this will do, it will check the character is A or A. So if that is the case, we found a vowel for the given input character. This one is a check use background check state, and if it is not in a checked state, here we are using the not equal to check state dot checked not. So if that's the case, what we do here, we are parsing the input A. So because this is the function for check vowel A, right? So that means we are concentrating on this one. So we read the content from this text box, then we are calling the try pass from the long utility, and in the output parameter, we will get the converted vowel count. So here if you see, vowel count is declared as long, so we will get a long value here. Then so that means there will be previous vowel count, right? So far, let's say during the processing we found 10 vowels, and the function is called for the 11th character, and if it is a vowel, then we need to get the previous text, and we are incrementing it vowel count as 11. Then text a dot text vowel count dot to string, then we are assigning that vowel count to text. So here count a, we are incrementing it to 1. So here you are just seeing one vowel count, check vowel a. So we have to write similar function for other character also. Check vowel e, check vowel I, o, u. So all those stuff we have to write. When we go to the code demo, that time we will place all the 5 functions. So here we are talking about this variable, right? So the variable b, if you see, it is accessed by both the thread, and we have UI thread and worker thread. So the worker thread will perform the write operation, and this portion, if you see the highlighted portion, this portion, let's say this is A, B, C, this is not used when the worker component is in picture. So when it is in worker component, we are not using this variable at all. So what we are doing, since this code will run in the main thread itself, because it's not a worker component, the function is check vowel a, and we will not land here in this piece of code when we are using the background worker component. So this code will reach in a normal execution, or in a normal execution. If you see chk use background check state is in not checked, that means in normal flow, and this one will be used by the worker component, worker thread. So worker thread, if you see, it's not accessing the UI. Here we are doing the this is a read operation, this will be the write operation, right? In normal flow we are making use of this component directly, but when it is a worker thread, we just increment this counter. So check vowel a, and this is the if condition, and if background worker checkbox is in checked state, we land here and we just increment the counter. So updating the UI, all those stuff we will see later. For now we are just incrementing this counter, but this counter variable we are not using it here at all. But when we use the background worker component, that time we will perform a write operation. This is write operation, right? So in the UI thread we will just do a read operation. So we are not mixing read and write between these two threads. So that way we are pretending to make the variables thread safe. Alright, so for now just concentrate this if portion. In the if portion we are reading the text, then we are updating the vowel counter, then we are putting back the incremented vowel counter here. If a is found, we are incrementing whatever is there in the content. If it was 10, then we increment it to 11 when we found one vowel. So this happens during the normal workflow. Alright, now let's move on. Here if you see, we have start count, and when btn start click is happened, that means when user clicked here, first we will say cancel work as false, then we will increment all these, we will initialize all this to 0. So This counter we will use when background worker component is in picture. And so during the start count we have to increment all this. So in this video we are not going to use this counter, but when background worker component events we implement, that time we will use this counter. So here use background chk use background dot check state is not checked. This is the one. So if it is like this, it's not in checked state, we will end up here. And if you see, we make a call to a function do without background worker. So this function we will implement here in this video itself. Otherwise user actually placed a check mark here. So if that's the case, if you see, this is our background worker component and we make call to run worker async function. In the previous video we saw about this function. This will raise an event do work, and when you provide a handler for do work, this handler will get called and this will run on a separate thread, let's say th2 thread 2. Alright, so that's what we are doing on this start button click handler. We are initializing cancel work to false, then we are initializing the counters. This is for count meter. Then when we are not using the worker thread, we make a call to do without bk grd background, some function method name we provided. Otherwise we make a call to the background worker component run worker async. So this will raise a do work and do work handler. In this video we are going to provide a dummy handler only, and in the next coming video we will implement the code. But we will implement the function do without background worker. The function A we will implement here in this video. So this is our multi-line text component, right? Here we have some sample text content, and we are going to count vowels from this content only. So we will perform a scan top to bottom, character by character we will read this text content, then we will check for the vowel count a, e, I, o, u. So what we are doing, first we are reading the text content and we are storing it as a string, then we are finding the length. Then based on this length we are calculating the progress increment. This is 100, that means for 1% how many character, that's what we are reading, we are calculating here. So for example the number of character here is 100, that means the length is 100 divided by 100, that means 1% equal to 1 character. So if it is 10,000 character, then length will be 10,000 divided by 100. 100 character will yield 1%. So that's the progress increment, and we will use this when we report the progress later. Alright, then we are converting this str content, we already read it from the multi-line text box. The toChar array function will give the characters array. So if there are 100 characters in this multi-line text, then we will have an array of character ranging from index 0 to 99. Next, if you see, since we have array of character, we are running a loop. So based on length we are running it, and since index starts from 0, length, if there are 1000 character, we run this loop till 999 if there are 1000 character. Alright, first we are checking inside the loop, we are checking if cancel work is set to false, that means I can proceed with the task. If cancel work is true, then we will land to else portion. First let us look at user doesn't click the cancel and cancel work is still in false state. Then we land up with the code snippet A. In code snippet A, if you see, we have the array of character, right? We are processing the character one by one, so we iterate single character and we keep it here in character variable C. So then we update the text count in progress. After that, if you see, we are making call to check vowel A, vowel E, I, O, U. So these are all our vowel check functions, and we in the previous slide we saw it. And when we are not using the worker component, we will land here, and you know what happens here. So we will update the count meter, and we will check for the vowel, and we will update the count meter. So this is for vowel A, right? If it is for vowel E, instead of checking A, here we will check E, and we will update the corresponding component. Instead of text A, we will update text E. So that's what here the first part of the code is doing. And if cancel work is opted by the user, then we reset all our counter to 0, and we will update the text LBL EVT complete. So this will be just above this multi-line text box. The label is invisible because we set auto size to true, so that's why you may not be able to see it in the previous screenshot. Alright, so this is the label we are updating. So when the count is going on, that means cancel work is false. Each time it will show count in progress, but when it is cancelled, we will land up here and we say count is cancelled. We also return from the function. So from do without bkgrd, from there we will return. Alright, so here there is one more portion. This is for the progress bar update. So progress increment, if you see here, iteration counter, let's say there are 1000 character. 1000 character means progress increment here will be 10. 10 character will yield to 1%. I mean 10 character will yield to 1%. And here if you see, we are using the iteration counter. That means let's assume that we are at here, this one. We are at iteration 500. That means we are processing the 500th character. 500 divided by progress increment. Progress increment is at 10. There are total 1000 character, right? That's what we assumed. That means 50%. 50% completed. That's what we will get. So we use this computed value to update our progress bar value. Progress b dot value equal to 50. 50 means 50%. Then a thread dot sleep 10. So progress bar, you can look at the properties. There we have the range as 0 to 100, minimum and maximum. Alright, then here we are putting a thread dot sleep. This is just to delay the process. So this will show the processing as a long running task. Otherwise we cannot experiment the BackgroundWorker component and how it is progress. We need a way to make this as a long running process. That's why we are keeping a sleep as a 10 here. So that's all. If you see, do work background, progress bar computation, character is, I mean, we read the character, we read the string content and we converted that into character. Here we are processing each and every character. And code snippet A, here if you see, we are making call to vowel count and we are updating the count meters. In B, we update the progress bar. In C, we say count cancelled. So this will be common for both BackgroundWorker worker component as well as a normal flow. Okay, alright, so it's not common. Here we are making call to do without background, right? So this is called only for the normal flow. That's all. Once the for loop is completed, this is for loop. Once it is completed, we say vowels counted. So our label here, so it will show the progress, count in progress, or count cancelled, or vowels counted once all the vowels are counted. So cancelling the task, once a user clicks this cancel button, we say cancel work to true. Then if it is a background worker component flow, chk use background.checkState, checkState.checked. That means user opted for background worker process. In that case, we make a call to cancel async. So this cancel async will cancel the do work event handler function, but this method to work, we need to set the boolean property to true, which we discussed in the previous video. That's all here. Now we will go to demo. We will click this BCK thread. Let's bring this property window. So this is the property. Worker supports cancellation. So we set it to true. In the slide we saw that, right? When cancel is clicked, we make a call to BCK thread async cancel. Alright, now we will implement the event do work. We'll go back to the design, progress changed, run worker completed. So we just kept some dummy implementation. We will implement these later. In the slide you saw we are using thread.sleep, right? For that we need to import this system.threading namespace. Next, at class level, we declare the required variables, cancel work flaws. Then these are all for the counter increment. We will use this later in the do work method. Next, we need to have the vowel counting functions. And if you see, we have 5 functions: check vowel A, check vowel E. So in the slide we just saw only this function, and the code is similar. This is for E, and you can see we are updating the variable related to E and text component related to E. This is for I, O, and U. Code snippet is available in the video description. Check for it. So next we need to handle this start count. Okay, that's for the class. And the code was already explained. This is for background worker, and this is for a normal flow. We are initializing. So in the slide we shown only this. We need to initialize this background worker component counter also. Then when the specific checkbox use background worker, chk use background, when that is in not in checked state. Here we are using the not operator, right? Not checked. That time we call do without background. Otherwise we may call to our background worker components run worker async method. Here if you see, we are implementing the do without background, and here is the do without background. This will get called when worker thread is not activated. That means in the normal workflow we call this. So that's what we implemented here. The code was already explained in the slide. These stuff are already explained. We will handle this cancel click as well. So if you see here, during each iteration we will check this cancel work is true or false. So the moment we see cancel work is true, we land up here, we say the count is cancelled, and we reset our count meter. And when btn cancel is clicked, we set this cancel work to true. So this cancel work is used only by the normal flow. For background worker component, we doesn't use this cancel work. That's why we are checking whether background worker is in picture. We state bck thread dot cancel async. So this cancel async will cancel the long running task. To enable that, or to make that function to work, you have to set worker supports cancellation property to true. Alright, now we implemented the code. We will build this once. It shows rebuild all succeeded, and we will start the count operation. First time we won't disturb this UI. And if you see, the counter is not updating. Since it's a busy task, only progress bar is getting updated. So once this operation is completed, then only the label is updated and the count meter also updated. So at least progress bar gets updated. Now we will start the count again. Now let me try to move this window. If you see, it doesn't move, and when I repeated it, we are getting not responding. So if I try to click any of the controls, say for example, okay, the counter is completed, let me start it again. And if you see, I'm trying to move it, it doesn't work. And if I click somewhere here in the window, it goes in a semi-transparent state. It states that the application is busy. Let me do this once again. This time I will click 2 or 3 times. If you see, when I try to interact with this UI, Windows is stating that the application is busy, please wait. And you also see the hourglass. That's all. So once the long running task is completed, then only I am able to interact with this UI. And we will do it one more time. This time the user want to cancel it, but they cannot do. See, it gone into non-responding state. That means I'm not even able to cancel the counting task. So it's all because of a single threaded approach. So in the previous videos we learned that there will be only one thread, and when one event under the UI thread is in progress, the next UI event will wait in the queue. So the start count, so this is one UI action, right? It is doing a long running task. So now I am producing the one more event. So this event will stay in the queue till the task get finished. So you are seeing it like the application is hanging or not responding. Alright, in the next two videos we will rectify all these issues. So the issues are, I am not able to interact with the UI. Next, I am not able to cancel the long running task. So those are all the issues at this moment. Alright, code you can download it from the video description. Thank you for watching. Bye.